Hi, hello everyone. Welcome to the Geography 361 lab. Lab 5. In this video, I will go through the questions 3 and demonstrate how to calculate the answer of the question 3. First, you can have several seconds to read the question. You can pause this video after you finish your reading. After you finish your reading, or you have read that, you can continue this video. In this video, the question is asking you to compare two average value of two groups. So let's say one of the hypotheses is these two groups has difference, and the other hypothesis is this two group has no differences. Let's draw our graph here. So we can draw one t distribution curve. And see the average of the average weight of the freshman is the average 1 or mean 1. Here I just call this to mean 1 and minus the mean 2. Mean 2 represents the weight of the juniors. So if there is no difference between these two groups, then their average value should be 0 or close to 0. If there is a difference between average 1, mean 1, and the mean 2, then their difference should be a large value. Or it should be a very small negative value. Right? Then go back to our graph. So we can see in the middle part, they close to 0. And in the height part or the tail part, it should be a very small negative value or a very large positive value. So based on this graph, we can see the non-hypothesis is no differences in weight between freshmen and juniors. And alternative hypothesis represented by the height part or represented by the height part or represented by the tail part, which means the differences in weight, the differences exist between freshmen and juniors. There is differences in width. No differences in width between. Okay, so this is our non-hypothesis and alternative hypothesis. To compare the average from two groups, we should use the C-test or the T-test. For this question, since the sample size is very small, we can see we only have 10 samples in each group. Then we should use the t-test. In Professor Chen's lecture, we can find the equation here. Okay. These two slides are the equations to compare the means from two different populations. But they have two situations. One is for equal variance, and the other for the unequal variance. So we first need to figure out which equation we should use by comparing their variance. How to compare their variance? We should use the f-test. So let's should write our hypothesis for the equal or unequal variance. First, I want to write down the equation of the f-score. The f-score equals to the variation of group 1 divided by the variation of group 2, right? So let's analyze this equation. Let me draw one F distribution curve first. This is the F curve. Okay, since the variation 1 and the variation 2 should always be the positive value, then the F-score will never be the negative value. If the variation 1 and the variation 2 are very similar, or the variation 1 equals to the variation 2, then the F-score should be equals to 1 or should close to 1, right? Because these two numbers are the same. But in another situation, if the variation 1 and the variation 2 has some significant differences, in this case, the F-score should be a very large value. So let's show this on the curve. Here is the 1. If the variation 1 and the variation 2 equals to 1, it means they are within this range, in the middle part. Since we always use the large number divided by the small number, so the f-test is not a bell form curve, it's a long tail curve. And if the f value is very large, then the f-score will very large. It's represented by the tail parts. So let's write our non-hypothesis and our alternative hypothesis for the f-test. The non-hypothesis is their variance are equal. And the alternative hypothesis is their variance are unequal. Let's delete our draft and post our equation under the hypothesis. To calculate the variation 1 and the variation 2, you can just put your data in the Excel and then use the function in the Excel to calculate the variance. Then you can calculate the F-score. It's just use the large variation divided by the small variation. So here we can see the F-score is 1.92. Next, we need to figure out the critical F value. You can find the F table in the Blackboard under the lab5 section. Here you can find that one file called ftable.pdf. You can open this one to figure out the critical F value. So the first row and the first column represent the freedom of the the two freedom of the F distribution. In our question, we have 10 samples in each group. The degree of freedom equals to the sample size of the group minus 1. So for each group, our degree of freedom are both 9. So we can find the first degree of freedom is 9 here, right? And then we find the second one is 9. Our alpha value is 0.05. If we do not mention the alpha value specially, the default alpha value is 0.05. We can find this value is our critical F value. Let's mark here. Because this is 9. And the first degree freedom is 9. And our alpha value is 0.05. Then our critical value is 3.18. So the F critical is 3.18. Let's go back to our F curve. The critical value, I will use the green marker here, is 3.18. If your F value greater than 3.18 here, which means you should reject your H0. You should reject your non-hypothesis. But here, our calculated F value is 1.92, which is smaller than 3.18. So it may be here, 1.91, smaller than 3.18. So we should accept our H0. Then we accept our H0, accept our non-hypothesis. We should choose the t-test equation for the eco-variance situation. Okay, let's go back to the slides. We should take advantage of this equation here. Let's write this equation in the answer sheet. remove that? No. Okay, just do it. Okay, nice. Let's clean this draft and write the equation under our hypothesis. The t should be average 1 minus average 2 then divided by this long equation for the standard deviation. To simplify, to make the calculation easier, we can also use the Excel to calculate the whole thing. So what we need here is the average of these two groups and the standard deviation. So let's go back to our Excel. First, we can figure out the average value of each group. Select the average function, then select all the data here. Here is our average value. Then we calculate the standard deviation of the x1 minus x2. So we can type the equation here. It's just our n1 is 10, 10 minus 1 is 9, 9 times the variation of group 1, then plus the n2 minus 1, n2 is 10, 10, 2, n2 is 10, 10 minus 1 is 9, 9 times the variation of group 2, right? Divided by the n1 plus n2 minus 2, which is 10 plus 10 minus 2 is 18. Okay. The index of this part is 0.5, which means we root mean. We root square of this part. Right. The second part is the 20, which is the sum of 10 plus 10 divided by the product of n1 and n2 is 100. Then here is just the standard deviation of x1 minus x2. So we can open our Word and write the equation here. Let's leave some blank for the for the Excel. The average of first one divided by the second one. The average of first group minus average of the second group, then divided by the standard deviation of x1 minus x2, which is here, we just calculated, is 3.41. So we can use the Google to calculate this equation. The result is 3.67. So next we need to figure out what is the critical t-value? We need to open our t-table again. In this t-table, first we need to figure out what is the significant level. So because the alpha equals to 0.02, so we need the data in this column here. And then we need to figure out the degree of freedom. So remember, this distribution is the average of the first variable minus the average of the second variable. So the degree of freedom for the average of first variable is the n minus 1. So it is 9. For the second one, it's also n minus 1, so it's 9. When we put these two together, it's 9 plus 9 is 18. So we need the data in this row and in this column. So we can figure out our critical t-value here is 2.101. So the t critical is 2.11. So we can see this number is greater than our t-value. Here is the 2.11. We can see this number is greater than our here 1.67. So which means we should accept our H0 hypothesis, which is represented by the middle part of this distribution. Okay. This is the answer for the question 3.